Everyone, welcome to the Kubernetes series that we have started on YouTube. And today we are going to discuss about the Kubernetes resource limit. And we will cover this complete video in theory as well as in the practical guide as well, right? So, and plus the bonus tip will be the interview preparations Q&As also we will discuss, right? So this is the index. If you see what we are going to cover, we are going to discuss about the resource limit, type of resource limits, okay, understanding CPU limits, CPU and memory units, right? And how it is getting calculated, then YAML files, okay, then pod behaviors basically we will see. Then we will see in-depth Q&As we will see that can be asked in your interviews, okay. Then quality of service we will see, limit range, practical guidelines and practical applications we will see, and then we will in the end we will see HPA and VPAs as well, right? So these all things we are going to cover. First we will go through the theory and then we will do everything on the demo as well. For that I have already written my three files here. So this is for the CPU utilization, this is memory, and this is for quality of service. So everything I will explain in the detail. Post that, after completing this video you will be very much comfortable in jobs in the Kubernetes. I mean, in the resource limit of the Kubernetes, right? So let's get started. So we will start like what is the resource limits here basically, right? So in Kubernetes, resource limits defines how much the CPU and the memory a container can use, right? So we already know that when we run a container inside the pod, we need the application which is running, we need to specify that how much it is going to use the CPU and memory for my application to run, right? And that limit can be done by using resource limit concept in Kubernetes. Okay, so these limits helps. Basically, what is the benefit of providing these limits here? It prevents from the container, I mean, it prevents the container from consuming excessive resource. Okay, it is very much possible that your single pod can consume whole node application. Okay, whole node, it can consume all the CPU and memory of the node it can consume. And if you are not limiting it, it is going to crash or you're going to impact your system, right? So that is why we have to ensure like, okay, there is definitely we should define a limit for a pod to use, okay, or a container to use inside the pod, right? Ensure fair resource sharing between the containers. Avoid over provisioning or crashing of nodes due to memory pressure. That's what we have discussed, right? So it is very much possible that your single pod can consume your whole node CPU and memory, and then it can impact it can impact your server, it can impact your application, and there will be a downtime if it is not handled properly, right? So Kubernetes use what under the resource limit? It use basically request and limit. Okay, so it will be divided into two parts. First will be request and then it will be limits. Okay, what is request here? So it is request means the minimum guaranteed resource assigned to a container, right? So let's say if you are saying uh, in my whenever my container is going to start inside the pod, I need minimum X amount of CPU, X percentage of CPU or Y percentage of memory there, right? Whereas limit says the maximum resource a container is used to allowed, right? So when you define the limit, right, you say that okay, more than this, more than X percentage or Y percentage, my pod or my container should not use the memory or the CPU, right? So that kind of limitations you can set using request and limits. That kind of bar you can set here basically, right? So why resource limit are important? Let's understand with the real use cases. So if you are using a multi-tenant clusters, right? So in case of multi-tenant cluster, it prevents users workload from starving others. So if you're, let's say you are running your application, it should not go ahead and impact another clusters as well, right? So in that case you should use you should definitely in your manifest file you should definitely include resource limits. Second is predictable performance. So you do not want it to impact your other pods or application. For that, cost control. So you do not want as well, like, okay, your node capacity is taking more CPU, high utilization is happening there. So to optimize that, you have to ensure, like, okay, resource limits are used. Then node stability, definitely, because if your memory is taking more percentage than your limit, then your pod is going to crash, right? And you will get an error called OOM, that is out of memory. Okay, so this error you will get. So we will see everything in the demo as well. Okay, so like, let's say, what are the types of resource limit? Okay, so first thing we have discussed is, when we create a resource limit, there are two types. One is request and limit, right? So under the request and limit also, it get divided into two main resources, that is CPU and memory, right? So request will also have CPU and memory, limits will also have CPU and memory. Now, what is CPU? We all know it is a central processing unit, but here it is like processing time on the node. Okay, and the unit is core per millicore, right? So vCPUs we say, right? 4 vCPU, 8 vCPUs, like that. Okay, what is memory? It is a RAM used by the container. It is used in either bytes. Okay, and then MIGI. What is MIGI? We are going to see in the uh, next page basically. So MI also called, we says as maybe byte. Okay, GI means GB byte, right? So this is maybe byte and this is GB byte. Additionally, there are two types of resource configurations we can do. Okay, this is one thing, right? You can do based on the CPU and memory. On top of it also, you can do two other type of resource configuration. One is container level limits you can define. Okay, so you need to create a YAML file where you can define container level limits as well. If you want, you can also define at a a namespace level, that is called limit range. Okay, so via limit range, you can also set a limit on the namespace level. So let's say if you do not want it to include resource limits, then in that case, you need to use limit range, right? So this is the additional concept basically we should be aware of. Okay, now it is very important to understand these terms. MI, what is MI and GI? Because when we start, we get confused, right? Because generally we see MB, megabyte or gigabyte, right? But this is where we are seeing maybe byte and GB byte. So that's a new concept, right? So let's understand that part also. What are the different units we say in Kubernetes when we declare in the manifest file? Okay, so Kubernetes basically allows memory limit both in binary or in a decimal. That is, binary means base 2 and base 10. But MI and GI, that is maybe byte and GB byte, are the most common recommended are the most common, and they are recommended in the YAML manifest file. Okay, you can use both. I mean, both will be, but the recommendation is like to use MI and GI, right? So how it starts unit wise? So first is KI, that is KB byte. 1 KB byte equals to 1024 byte. Okay, 1 MI, that is maybe byte, equals to 1024 KI, right? Which is equivalent to 1048576 bytes, which is nearly to 1 MB. Okay, similarly 1 GB, 1 GI, that is GB byte. 1 GI is equals to 1024 MI, which is roughly is 1073741 bytes, which is close to 1 gigabyte as well. Okay, so in short, you can say, okay, 1 GB, you can say 1 gigabyte is quite equivalent or same. But when you are writing in the manifest file in YAML, or for when you are writing the request limits in YAML manifest file, you need to mention like GI instead of GB and MI instead of MB, right? So that part you can take care. Okay, so I hope this part is clear. So MI and GI this is the unit and size we have to use. Okay, and then what is the CPU unit in Kubernetes? So CPU units is in Kubernetes is, this is for the memory. Okay, so which we have discussed, right? Memory is always defined in MI and GI. Okay, but what is for the CPU? CPU is always used in core per millicores, right? So let's read about it. M stands for millicores. So CPU resources are measured in CPU cores, but since you often want to allocate fractions of the CPU, Kubernetes use millicore. What does it mean? Let me explain you. So 1000, let's understand this unit first. So 1000 millicore equals to one full CPU core. Okay, so if your system has 4 vCPU, that will be 4000. But let's understand for one CPU core. So one CPU core will be equivalent to 1000 millicore. If it is 500 millicore means half of your CPU core will be used. So half of the CPU core. If it is 250 means one quarter or 1 by 4 of the CPU core. 100 means 1 by 10th of your CPU core. It is just very simple maths. Okay, so if your node is having 4 vCPU, right? If your node is having 4 vCPU, then you can set your container limit to 500. And if you are setting your container limit, container CPU limit to 500 M, that is, so if you are setting up the container CPU limit is 500 millicores, okay, that is 500 M, then it means the container can use up to 0.5% of the 0.5, that is 50% of the CPU, right? Is it correct? No, right? Because what I'm trying to say is if you're using 4 vCPUs, if you have a 4 vCPUs and your container is set to limit of 500 M, that is 1 by 4 of your vCPU, right? Not 50%. So it is saying like that is half of one core. 0.5 means half of one core, but it is not half of 4 core. This is for 4 cores. You are using 500. If you have to use half of 4 vCPUs, then you have to use 2000, right? I hope you have got it. So the container can set up, so here when we are setting it as 500 M, the container can use up to 0.5, that is half of the CPU available of 4, half of one core basically, not of 4 cores, half of one cores, right? So let's understand with the analogy. Let's say if you have a 1 liter of water bottle, 1000 M means 5 full, right? Your one liter of water. 500 means your half water bottle, and 250 means it's a quarter. Okay, so you can check this in your local also, like how many vCPUs you have. So if you go to your command prompt, right? So and you just enter this, so it will tell you how many vCPUs and logical processors you have. So this command you can execute. Okay, going to the next part, how they are calculated internally. So Kubernetes schedule pods based on the request. Okay, what does it means? So whenever a new pod is coming, so initialization will always take care based on the request, not on the based on the limit. I will explain you in the detail about this statement. So basically, if we go here, yeah, we can find it here itself. So when we define the resource limits, there are two parts, right? Request and limit. And we discussed in the request and limit, both will have CPU and memory and CPU, memory and CPU. Okay, so whenever a pod is getting created, it will be always created based on the request. This will be the minimum resource required for the container to start. The Kubernetes starts the pod based on the request, not on the limits. For the limits, it will just exit it, or it will delete it, or it will throttle. Okay, so limits is used for those purposes. So it is saying that maximum number of resource it can use. So it can use minimum is 64 and 100 mi of 100 m millicores of CPU it can take to start your resource, that is your pod or container. but maximum it can use 128 MI and 200 millicore of CPU. That's the concept here. Okay, now next point is CPU is enforced using Linux CFS quota. What is CFS? It is completely fair scheduler quota specified under the CPU. Basically, it is under the GCPUs, G groups. Okay, G groups is nothing but a control groups, and it is a part of uh, Linux system. Okay, so memory is enforced using, so memory is always enforced using G groups. Okay, and CPU is enforced using CFS. CFS stands for completely fair scheduler quotas. Based on the Linux CFS quota, the CPU is given, or CPU is enforced, and memory is enforced using G groups, C groups, that is control groups. If it is exceeding the limits, the container is called container will be killed, or it is called an OOM killed, out of memory killed. Okay. Example wise, if a CPU is having 200 millicore and the node has one CPU, 250 millicore, and the node has one CPU, the Kubernetes will give your container 25% slice to the CPU scheduler. Who is CPU scheduler? It is CFS quota, completely fair scheduler. Okay, so 250 means 1/4, right? 1/4 of one CPU. So who will be taking care all this? So it is taken care by the Linux CFS quota. That's what I'm trying to say here. CPU scheduler, and memory will be taken care by C groups or control groups. Okay, so I hope this is clear. Now let's go understand the next part. More example about the, okay, this one we have already understood, like, okay, you can use it for small microservice applications, okay, where your Node.js goes, okay, so you can use there. Okay, let's understand, this is medium. For this one, here we are using 64 and 128 MI of memory. Here we are using 256 and 512 maybe byte. So it can be used for your Spring Boot APIs, Python, Django and all, right? So this can be used, and then you have heavy processing jobs where 1 GB of your 1 gigabyte gigabyte of your memory, and you can give up to 2. So it is for machine learning, batch jobs, DB loaders. So you can use this. So you are saying like, okay, you start with 1, but you do not cross more than 2 gigabyte, right? So that's the concept here. Next one is balanced resource also, right? So what is this balanced resource? When we say balanced resource, if you see, if you notice, your request and limits are same, right? So request is 256, CPU is 250. Request is memory here is 256 and CPU is also 250. So both the details are matching here. So when we see this kind of thing, it is called balance resource. Okay, so it is mission critical apps, right? That must be always get their guaranteed resource. So this is quality of service. So I'm going to demo all those things in the next chapter as well. What is quality of service and how we use this quality of service. Okay, so what is this setting resource limit? So this is the same concept. Basically, it is using some image, and then this is your resource. You are setting up the resource and you are setting up the limit. Okay, so you are giving 64 MI and 250 millicore and 128 megabyte and 500 millicore. So you are saying more than this you do not use when you are running this pod. The name of the pod is resource limit pod. This is just an example. So that's what we have just now discussed. Resource request 64 maybe byte and 250 millicore of CPU. Limit range is this one, and run a stress command and consume memory, right? Okay, so this we will see in the demo. Okay, what is this? Best practices for resource limit. Always set resource limit and resource and limit for the production workload. That's true, right? We should we should not use a pod without having a resource limit, because it otherwise your pod can take huge amount of memory and a CPU, and which can block your node, right? And it will impact your application. Use limit range and resource quota for multi-tenant namespaces. Okay, what is this? Use monitoring tools like kubectl. Okay, this is for monitoring tool. Avoid overly tight limits for yeah, that's fine. So let's understand, now we are in the middle of this, and now we have to understand about the interviews Q&As. Okay, so let's go through each and everything. So what is the resource limit? It can be asked in your interview as well. What are the resource limit and request in the Kubernetes? So we have already discussed. So in Kubernetes, a resource request and limits define how much CPU and memory a container can expect to use. Okay, or it is allowed to use. Okay, requests are the minimum resource guaranteed for a container. That whenever, why it is guaranteed for a container? Because whenever a container will start, that will be the minimum resource. So that is why it is guaranteed. A container will not start until unless it will not get the request resources, whatever you are setting up. Okay, so Kubernetes use them to schedule pods on the appropriate nodes. That is fine. Limits are the maximum resource a container can consume. Very simple definition here. It cannot consume more than the limits you have set up for CPU and memory. If a container exceeds the limit, Kubernetes may throttle for the CPU and kill the container in case of memory if it is exceeding. Okay, so if CPU is exceeding, it will be get throttled, your application will be slow and all. And if your memory is getting increased, then it will kill the container. Your pod will be in crash backlog. Okay, so last thing is, this approach enables Kubernetes for safely packed multiple workloads on a node without letting a single container consume all available resource. That's true, right? This help us to basically your single application should not consume all the node space, your CPU and memory, and multiple pods can run into your node. That's it. It is going to ensure this part. Okay. How are they used in control resource usage of container? How are they used for control resource usage? Okay, so resource requests are and limits are declared inside the container within container specification within a pod manifestation. Kubernetes used them in two ways. One is during scheduling or during execution, right? So basically, when we say during scheduling, what happens here is, the scheduler plays the pod onto the nodes and have enough unallocated CPU and satisfy the request. So scheduler will only place the pods into the nodes when there is a enough allocation of CPU is present. That's what we have discussed. While during, because until unless you will not get the CPU and memory, your schedule during the scheduling, your pods will not be deployed. And during execution, what it checks is what is your current CPU and memory. And if it is exceeding, then it will get throttled or it will get killed by in case of memory. That's what it is saying. The Kubernetes enforce limit at runtime. At runtime, it will keep on checking. Like if a container exceeds the limit of the CPU, it will get throttled. And if it is memory is exceeding, then it will be an ohm killed. Okay, if it is CPU exceeding, then it will be throttled. So basically it is very simple. What we are trying to say here is, so in there are two things. Whenever a pod is getting scheduled, the pod will be scheduled only if there is a enough memory and CPU is present. That is during the scheduling. And during execution, it will keep on checking, like if it is crossing the limit, then it will either get throttled or it will be ohm killed. This allow admin and developers to control, prevent noisy, and maintain the cluster stability. Right. So this we have already discussed how they are used for the control use resource usage. Okay, explain the difference between the request and limit. It is same thing we have already discussed. So request and limit. So it is the minimum guaranteed resource. The minimum it needs to get your pod started, and it is the maximum. So it cannot cross the maximum limit here. It is used by scheduler, okay, and it is used by kubelet. So on the runtime, who takes care of all this? So this activity is taken care by kubelet. Kubelet is an agent in the worker node, and this is the component in master node scheduler. Okay, so scheduler is going to put the pod in the node based on the available resource and memory, CPU and memory. What is enforcement? It is soft guaranteed and it is hard enforced. So it is softly put whenever the resource is there, and it is it is getting deleted, or it is getting killed or throttled whenever it is meeting the condition. CPU behavior, minimum CPU for fair scheduling, throttled if exceeded. This is already discussed. Memory behavior is reserve amount of for the container. It is reserved for the container, but it is killed if it is exceeding a limit. Default, what is the default? Not set by default unless limit range. So if you are not setting up, there is nothing called default. Okay, not enforced if not declared. So basically, until unless you are not declaring the resource limit, it is not going to work. Okay, so what next? What happens if a container exceeds its CPU and memory limit, right? So this already we know. If it is exceeding the memory limit, then in that case it will be killed. If it is exceeding the CPU limit, then it will call throttled. And perform your in this case your performance will be low, right? And in this case your Kubernetes may restart the pod itself. Okay, so this makes the memory limits fatal and CPU performance raise. So it is all performance and availability things if you are not taking care it properly. Next question is, what are the resource limit and resource request importance in the Kubernetes? That's we have already discussed. It gives the node stability, fair scheduling, cost efficiency. Okay, cost efficiency. It helps to helps to avoid the over provisioning, especially in the cloud. Predictable performance and quality of service. Ensure the right pod are evicted during the right point of time. In short, it aligns the reliability, efficiency, and cost of workload. This is important. Okay, now what is quality of service? This can also be asked in your interview questions. So quality of service, it's a see Kubernetes assign quality of service to each pod based on how container is defined. Okay, so quality of service can be of three types. One is guaranteed, bustable, and best effort. Best effort. What is guaranteed? All containers have equal memory and CPU for request and limit. Okay, so if both are having a equal memory and limit, CPU and limit request, then it is called guaranteed. What is bustable? Container have at least one resource request or limit define. So we'll discuss this bustable. Basically, your uh, your request will have low and I mean some values will be there, and then your limit will have some values. Let's say 10 here and 20 here. So after 20, it will be bust. I mean your pod will get deleted, or it will exit. It will come out with exit code. Okay, so that is called bustable. It basically it helps to control your application more better. So if it is crossing some certain limit, then it will get burst. What is best effort? So there is no resource limit are defined. Okay, resource or limits are defined. So in this case, it is very dangerous. So you should not use it. You can use it in your uh, test or dev environment. Okay, I think we should use this table. So you see request versus limit. So what happens is guaranteed a request equals to limit for all the resources. So if you are requesting CPU, request will be 250, limits also have a 250. That's kind of thing is called guaranteed. Scheduling priority is high. Okay. Eviction is lowest. It will get evicted in the last. So critical for production workload. So guaranteed you should define when you are using a production workload. Okay. Burstable, when your request set limit is greater than request. That's what we have said, right? So let's say your request is 200 MI and limit is 250. Like that you can do. So medium is the eviction is middle. So first who will get out? First it will be best effort because there is no limit assigned to it, no resource, no limit. So Kubernetes will kill this immediately, and then this burstable pods will get evicted only if it is meeting the conditions. So it is in middle, priority is middle, and then lowest is for guaranteed because this will complete the job and it is used for the production work. The scheduling priority is lowest for this one, and non-critical dev and batch job scale we can use QoS, best effort basically. Okay, so there are so many things still to discuss, but let's continue. How do they relate to resource request and limits? So QoS is entirely determine the request and limits. So this we already discussed. Okay, so this is nothing new. We have already discussed this question. What are the limit range and how they are used in Kubernetes? So this already we know what is the min and max. So okay, so this limit range we have not discussed. So limit range is a namespace level object, right? You remembered on the top we have discussed here, right? Along apart from CPU and memory resource limit, we can also do container level limits and namespace level limits using limit range, right? So let's understand what is this limit range. Question number 7, I think. Okay, so limit range, if you see, limit range is a namespace level object that defines default resource request and limits for the pod. Okay, the minimum and maximum value allowed here in this case. So in this case, when we are defining the limit range, we are not giving here resource and limit. You see, it is a different object itself. The kind is of limit range. You have to declare a limit range, its name and what namespaces you wanted to keep. On top of namespace, now the limits are defined. On the dev namespace, there is a limit is defined. So limit is by default, your memory is 512 MI and one CPU you can use, one core of okay, that's and the default request is, so this is request 256 should be starting, 5 minimum is 500 and maximum can go to one core vCPU. Okay, and the type is container. So basically this is how you can define limit range. Important thing to note, this is a different kind itself, object itself. And API version we use here is v1. And this is applied on the namespace level. So this limit is applied on the namespace level. Okay, so limit range we have discussed. So this ensures even if the user forget to apply request limit, the pod still runs with the default, right? So since it is applied on the namespace level, not on the pod level. So this is the next level of security you can or filtration you can provide. Definitely we should use limit range as well. Okay, what are the advantages and disadvantages of limit range and per pod limit? Okay, so limit range, what is the advantage? Automates consistency, avoid mistakes, precise control per container. Disadvantages, maybe not suitable for all workload, and this is for easy to forget and misconfuse. Yeah, this is important, right? Maybe when you are configuring at a pod level, you are missing the for each pod when you are declaring or under the deployment, you might miss the resource and limit. But if you are setting it up at the namespace level, you do not have to worry about the for each resource whenever you are declaring. So this should be a very good option. I think we should definitely use at a namespace level. Okay, so namespace level governance, whenever you are using, you should use limit range. And fine grained control, if you are very much sure that okay, we are not going to do mistakes, and each resource whenever, or each pod when we will declare, we will define the resource and limit conditions of CPU and memory, then you go ahead with the per pod limit as well. Okay, so limit range is the best for defaulting and governing team, while per pod limit is good for custom tuning. Okay, so this is what we have discussed. Practical application and troubleshooting, how do you define resource limit and request in the pod manifest. So this we already know. Under the request and limits, we define memory and CPU. So this we already know. How do you troubleshoot a pod with frequently killed ohm? Okay, so in this case, what you have to do is, let's say if your memory limit is crossed, then in that case, I will show everything in demo as well, but you need to uh, write this command, basically kubectl describe your pod name. Okay, then you will see your state. You can check the event as well, and then you can check log as well, and then based on that you can go ahead and if it is ohm killed, then definitely you need to go and increase your memory, right? Describe a scenario where setting resource limit is crucial. So okay, so a bad job is processing a file and sometimes spikes memory to 1 GB temporarily. So without limits, it could consume 2 GB and crash the node. With limit, you have to set like this. Now it has enough for the normal and peak loads, but it prevents from the harming other pods. So you are doing a bad jobs and you know that okay, temporarily it can take one up to 1 GB. Okay, so in that case, you just set up the memory like this. Okay, I will set up okay, minimum request, it should start with 512 and it can go up to 1. Okay, so you know the max, so this spikes and all you know, and based on that you can set up the limits, resource limit. This is for your monitoring tools. Okay, fine. What are the potential consequences for not setting resource limit or request? Overcommitment, OM crash, unfair usage, no quality of service, hard to debug. These are the potential consequences of not setting the resource limit or request. Explain how Kubernetes handle resource contentions. So when a multiple pods complete the limited resource, memory, kubelet start evicting the pod on quality of service, and on CPU, containers if it is, then it will get throttled. In short, pod with the better resource definitions are treated with as more important during contention. How can you ensure the Kubernetes cluster is not over provisioned? So then you have to set resource limit and request. Use request wisely and do not set too high. Regularly audit, implement HPA and VPA for auto scaling. Okay, horizontal pod auto scaling, vertical. Next is use limit range to apply. Okay, at default, reclaim over allocation resource and use quota resource quota. What are the common mistakes when setting the resource limit? Request equals to limit equal to high value. Got node underutilized. Not setting any request limit, that's a problem. Using same values for app regardless of load. Overturning in dev and test environment, ignoring actual usage data. So these all things we should, as a Kubernetes engineer, we should be taking care. How you can edit a resource? So basically, you can go and edit into your deployment file, and then you can apply it. What is HPA? Horizontal pod autoscaler. So automatically adjust the pod count based on the CPU and memory. Okay, this is horizontal, Then vertical we will also see. So if you want declarative, imperative, so you can run this command kubectl autoscale deployment, and your deployment name when CPU is 50, you have to what is the minimum and maximum you want. Okay, so what HPS is, HP automatically scales the number of pod in deployment, replica set or stateful set based on the CPU utilization and other metrics, right? Now how we declare the HPS, horizontal pod autoscaler. So you have to use API version called autoscaling/v2, and kind will be horizontal pod autoscaler. You can give any name here, and under the namespace, if you want default, then you can comment as well. It will automatically create under the default namespace. Okay, so this is spec. So this is spec, and then you have to define minimum replicas, minimum number of pods, HPA will scale down, and so minimum at least you need 2 pods, and maximum 10 pods, basically maximum number of pods HPA will scale up, right? And this is your metric and resource and limit you can set. Okay, so this is one thing. So explanation of HPS. So we have already discussed it uses auto scaling v2. Kind is of horizontal pod scaler. Okay, names, resource, this we already discussed. What is min max replication, and this all we have discussed. Okay, now let's understand the next concept here. What is VPS? So it is called virtual pod autoscaler. Okay, so HPS you can definitely use in your application, and it says that HPS, this HPML is robust starting point for implementing horizontal scaling based on the resource. I mean, this you should definitely use. Whenever your pod goes up and down, you can scale up or down. Okay, what is vertical pod autoscaler? So it adjusts the resource request for a container and use vertical, and the kind is of vertical pod autoscaler. But one caution is use VPA carefully because it is going to restart when the limit changes. Okay, so you have to use the kind as vertical pod autoscaler like this, and API version will be autoscaling.k8s.io/v1. Okay, so what is the minimum allowed? What is the maximum allowed? You can mention here. And the important thing to take care is update policy. You want the updation to happen by auto, off, initial, and recreate, right? So what is these concepts? So we can see here. So when you are setting it the update policy as auto, the the VPS will automatically update the resource request for the pods to apply the recommendation. This is ideal for automatic optimizations. When you have to keep it off, the VPS will only provide the recommendation and will not automatically update the pod. You would manually need to do these changes based on the recommendation. Okay, useful for observing on initial testing. What is initial? The VPS only set the resource request when a pod is first created. It won't modify existing pods. What is recreate? The VPS will evict the recreated pod, evict and recreate pods with updated resource request when the recommendation changes. This is similar to auto, but specifically states that recreation will happen. Okay, so this you can use in the update policy. Okay, so I hope you have understood vertical pod autoscaler as well, how to use and when to use. Okay, so one more important thing is before you apply the VPS, what you need to do is you need to install the vertical pod autoscaler. How you'll do the vertical pod autoscaler is usually installed as a separate component on your Kubernetes cluster. It is not part of your default Kubernetes installation. You need to follow the VPA installation guide for your specific Kubernetes environment. Ensure target deployment. Make sure the deployment stateful or daemon set you are targeting with the VPA actually exists in the cluster. After applying the VPA, monitor your application behavior and VPA recommendation based on kubectl. Get VPA and your VPA name, your metadata name, and observing the pod events and resource usage. Okay, so if you are on right track, the API version for VPA is indeed this, and the kind is vertical pod autoscaler. Okay, so this we have discussed completely with the question and answer with the theory of resource limit. So most of the things will come from this topic only. I mean, if anything will come, whatever we have discussed should cover everything. And if in your interviews and all, it will be you will be able to answer the questions. Okay, now let's see here a couple of demo as well. So first thing is there is CPU throttling demo. Let's see this one where my CPU, my request is 100 millicore, right? And I'm saying that my limit is 200 millicore. Okay, what I will do is I will change it to 100 millicore and I will allow my pod, that is one pod is there, right? And I will allow my pod to use all the cores of my application or node, right? So let's get started and let's apply this file. Okay, I will open my command prompt and we'll apply kubectl apply -f. What file? CPU throttling demo.yaml. Throttling demo.yaml. Let's apply it. Okay, it is creating and I'm checking like, okay, what is the minimum? So I have given 100. Okay, so when I'm giving 100 here, so basically, let's understand this YAML file also. So imagine you are driving a Ferrari, but you are only allowed to drive with the speed of 220 kilometer per hour. That's what the CPU throttle does. Okay, it can go up to 2000 kilometer per hour, but you are saying that, okay, no, you go up to 20 kilometer per hour only, right? Kubernetes does not kill the container for CPU overuse, but it throttle them, basically slow down. That is why memory limits are deadly, basically OM kill, while CPU means just a slowness. Okay, so we have run this command kubectl apply. Oops, system is impacting. Okay, so kubectl apply we have done. Now let's run this command kubectl get pods. Okay, let's see whether the pods are ready. So it is created. Command is not copied. So what is this command? kubectl get pods where label is app equals to CPU throttling. Currently the container is in creating state. Okay, let it get created. Meanwhile, what we will do is once the pod is getting created, we will symmetric I have already in place. So kubectl got pod. Let's run this command. Okay, so my metric is already running. That's what I just wanted to show. And what we will do is let my pod get created. Container is in still creating state. Let's take my container name. Hopefully it should be ready by now. I mean pod name. Okay, so what we can see, the pod is in running state now, and it is using a CPU of 4%, right? Now let's do one thing. Let's wait for a couple of more seconds. 3%, 4%, like that it will use. Okay, 4%, 3%. Now let's do for the demo purpose. What we will do is we will ask it to go and use the 4 whole. So I will ask him to use 1000 millicore and I will apply the command kubectl apply resource configured, and let's wait from 3 it went to 6. Now you see 14. Now CPU has started growing up, right? The utilization is up and down now. Earlier it was less than 3, 4, like that it was there. Now it is 6. After some time you will say maybe seeing 14, 15, 7, like that it will keep on increasing based on the time. Now you see 18. So like that it will keep on increasing, right? And if I reduce it quickly, let's say again we'll say 200, control S for save, and let's apply the file again. So now it should come down. So it is taking the previous one, but yeah, let's wait for a couple of more seconds. Okay, so it is now saying like, okay, it got terminated because it was showing earlier higher. Now if I execute the command again, my pod is changed. kubectl get all. So it is throttling, terminating basically. I have applied again. New one, let me take. And let's change this pod. Now you see, again it is 1%. So it will be like 1%, 2%, 3%, 4%, not beyond that. Okay, so now let's delete this and let's go to the next demo, kubectl get all, and I will delete the deployment itself. kubectl delete. Okay, so it is getting cleared. Let it get cleared. Okay, next thing is we are going to learn about the memory hog. So what it is here is, so there is one pod, its name is memory hog, and I'm running a command. Basically this command is going to consume as much as memory it is possible for it. Okay, and then Kubernetes will kill the container with a status called om killed. So initially I am declaring here memory as 32 mi maybe byte, and limits is 64. So let's apply this file now, and then we'll keep on discussing kubectl apply -f memory hog. This one I want. Okay, so let this pod get created. It is creating. Okay, so what else we have to discuss here? So when the pod, because we are running a command here which is going to consume more and more memory, and starting it will start whenever it will get 32 maybe byte of memory, but it cannot go beyond this one, right? So let's keep on checking as well here. Okay, so what command we have to use? So let's take kubectl get pod memory hog. That's my command pod name. It is showing like crash loop back off. Why it is showing crash loop back off? Let's understand here. We will run the watch window. Let's keep on seeing. So this is saying like om killed, and it is having 2 restarts. Okay, if you will wait, it will keep on showing some of the logs as well. Basically, let's see the event basically. Okay, so here now it is showing crash loop back off. Okay, so since the memory is beyond this limit, so it got crash loop back off. Okay, now let's see the event, which will give more clarity actually. So running and then again home killed, out of memory killed, right? So here you see the status is home killed. What we can also do is we can run this event and here we'll get more logs. So it is scheduled, pulling, killing, pulling, pulled, started, successfully create, delete, pulling. Okay, so this is getting killed again and again whenever it is going beyond the limit after it is starting. Okay, so somewhere it is created and then it started, killed. Then again it is scheduled, right? See, it is now running condition. It is saying it is running, but once the memory will go beyond 64 maybe byte, it is saying that, okay, sorry, I'm again crashed, home killed, right? So this you have understood. I think we have understood in the live. So this example is critical and I think we are able to execute as well on the live session. Okay, so last thing here is, let me delete this kubectl apply and then let's delete this resource as well. Okay, so the last is QoS, quality of service demo. So this YAML is going to demonstrate about the quality of service classes, what is guaranteed, burstable, and best effort. Okay, so what we have discussed, I think this we have discussed in the example also. So basically, there is one deployment, and in the deployment, the important why we are saying it as a guaranteed because your request and limits both are same. Your CPU is 100 millicore, CPU is 100 millicore limit also. Memory is 100 MB byte, memory is 100 MB byte. So request is equals to the limit. Okay, so this kind of resource limit is called quality of class guaranteed. Since the request equals to limit, Kubernetes reserve those exact resources for this pod. Okay, so it will first reserve the limit for the pod. Okay, so Kubernetes give highest priority for this kind of pod. This means the pod cannot use more than limit, which equals to the request. It won't be throttled or evicted easily. The pod gets highest scheduling priority and stability. Your app is guaranteed the resource it needs to run properly. No surprises. Basically, your app will continue to run and it will get whatever it has requested. It reduces the risk of pod being killed under the node pressure whenever CPU or memory goes high. Critical for your databases or production load bases and all. What is QoS burstable? So burstable, if you see your memory, your request starting point will be less. Your start memory request will be less, 50 and 50 MI, and your limit says 200. So you are saying that okay, start with 50, but you should not go beyond the limit which I'm mentioning, that is 200 or 200 MI, right? So this is the medium priority thing, and it get evicted after best effort, but before guaranteed. So guaranteed get evicted in the last. Before that, bustable, and then the first one which to get evicted is best effort. It can be used for the app services, worker services, and maybe need for burstable load, work kind of load. So when you need that, okay, let it start with 550 MI millicore or 50 maybe byte, but it should not go beyond this one and let it crash or get deleted. So you can set up this kind of environment there. What is best effort? So best effort, there is no limit or resources set up here. Okay, so this is very dangerous, and you should use only in the test environment if you are using, and it can get deleted or evicted at any point of time under the node pressure if the CPU utilization, because this is going to create your pod, and it is allowed to use whatever space or memory and CPU it wants, the application wants. Okay, so there is no restriction or there is no limit for this kind of thing. Okay, so I hope you have liked and enjoyed this session. It is long video of 1 hour, but it contains all the information. If you need this uh, document also, please feel free to ping in the chat of this video. I will share with you, or I'll share the shareable link of this document. Okay, thank you everyone. Have a great day, and please like, share, and subscribe to the channel. We'll meet in the next recording.